Hello everyone. Thank you for attending the conference and this talk on Jupytext. And also thank you to the organizers for the great online conference. My name is Marc Wouts. I am a researcher at Capital Fund Management in Paris. I am a mathematician by training and I am also the author of Jupytext. So first, why Jupytext? Jupyter Notebooks are great and everyone uses them for a good reason. But I see a few limitations to ipynb files. You can only edit them in Jupyter, while you would appreciate to open them in your text editor. And they are not so well suited for version control because they are JSON files, so a bit hard to merge. And also they are often large because of outputs. The idea behind Jupytext is to keep using Jupyter Notebooks, but only to store them in a format that makes sense outside of Jupyter, in files that you can open and reuse outside of Jupyter. The formats that are supported by Jupytext are scripts in many languages and Markdown files. Let me say a word about how you install Jupytext and what difference it makes to your user interface. So you install it with pip or with conda, and then you just need to restart Jupyter. And as you see, there's a major change in your user interface. The py and md files now have a notebook icon. And by this, this means that you can really open them as notebooks. So we continue with a demo. I have prepared an example.py file, which is this one. So it is a very simple file. I load the dataset and then we do a quick plot of the dataset. So I go to Jupyter Lab. As I have Jupytext installed, this file has a notebook icon, and I can right-click and open it with Notebook, which I do. This file really is a notebook, so it behaves like a regular notebook. I can execute it. I can also obviously modify it. Let me add a title, for instance. Right, and I execute this one. So let's see what was the impact of doing this on the py file. I go back to my text editor, and you see that this new cell that I have just added now appears in my py file. I also see additional blank lines at the end. These blank lines correspond to the cell that was added after fix.show when I run the notebook. I am also free to edit this file in my text editor. So let me do this. I save, and I go back to Jupyter Lab. The notebook is loaded in memory, so we don't see an effect yet of having changed the cell 5. So let me go to File and reload Python file from disk. When I do reload, I get the latest title, but it is a bit unfortunate. I have lost the outputs. And this, you clearly understand why this occurred, because outputs are not saved in the py file. We will have a solution to that in a minute. Let me show you something else. So I'm going to run only the last two cells, the fig.show, and we change the title, and it works. And the fact that it works means that the Python variables, when we reloaded, were not erased. So we still have access to the latest variables in the kernel. So reloading is a bit inconvenient when we lose the outputs, but we don't lose the variables. And in a minute, with paired notebooks, we won't even lose the outputs. Let me add a word about metadata. So this information that the notebook should run with the Jupytext demo environment, maybe I want to store it in the text file. So this is an example of metadata. You can have both notebook metadata and cell metadata in Jupytext files. So for this, I search for metadata in the Jupyter command. I check include metadata, and I save. If I go back to my py file, then you see that adding the metadata caused the addition of a new YAML header at the top of my file. And here I do have information about the kernel in this file now. I will now describe how we solve this problem of outputs that are lost when we reload a text notebook. So the solution is to use paired notebooks. So the notebooks is saved both to an ipynb, a regular ipynb file, and the py file. When we save to the two files, and when we load the notebook, we load the outputs from the ipynb file, and we load the inputs preferentially from the py file. How you create a pair notebook? It's very simple. You search for pair in the Jupyter commands. So here, since this is a py file, I have the option to pair with an ipynb document. And if it was an ipynb file, then I would have the option to pair with a script or with a Markdown file. So let me select this one, go back to the file window. And when I save, as I said, the notebook is saved to both the py file and an ipynb file. I'm going to show you that these pair notebooks are super robust. You can delete any member of a pair, and when you open the other one and when you save, the missing member is recreated. Which means that if you use Jupytext for version control, then you can share just one of the two files, and the other one will be recreated when the user opens the notebook, runs it, and saves it. If you're using Jupytext for version control, probably you will want to share just the text file, which your collaborator will open as a notebook, as we showed at the beginning of the demo. How to pair notebooks. So I have shown how to pair individual notebooks in Jupyter. So for this, we have used the Jupyter commands in Jupyter Lab. In Jupyter Notebook, it works the same. You go, but you use the menu. You go to File, Jupytext, and then you have the option to pair notebooks. You can also pair notebooks globally using a configuration file. So there's more detail in the documentation of Jupytext, but basically it is very simple. You create jupytext.toml file with this content, and then every ipynb file will be paired to a py notebook. Jupytext at the command line. So Jupytext is also available at the command line if you need to. You can convert notebooks to Markdown or to script using these commands. It's like Jupyter NB convert. You can convert back to notebook. That is the difference with Jupyter NB convert. You can convert back to notebook and preserve the outputs in case your notebook already exists. I mean the ipynb file. If you want to preserve the outputs, then you use ---- update. You can also pair notebooks at the command line. So for this, you use Jupytext set format. And you can synchronize paired notebooks in case you edit them outside of Jupyter. What can I do with Jupytext? So the first use case was version control. Jupytext formats are concise and the differences are very clean. Merging notebooks is also way easier with py and md files than with JSON. So it will be easier to merge notebooks with Jupytext. Writing notebooks is also way easier. You can copy-paste content from other notebooks. You can concatenate notebooks at will. And also you are free to edit your notebook in your favorite text editor. So if you like the advanced completion or navigation functionalities of your text editor, then you can use them. Obviously, you are also free to edit your notebook in Jupyter. Searching in notebooks is easier with notebooks represented as text. Refactoring your notebooks into libraries is also very accessible because you access to your notebooks as scripts, so you can identify the function you want to refactor and move it to a library. Then you will have the option to document and test it, so make it even safer. If you like to apply code style on scripts, then you can do the same on notebooks. It is just a matter of piping the notebook as represented as a script onto these tools. Why are there so many Jupytext formats? So again, this is a link to the documentation. And the reason is that you will be doing different things with them. So for now, we have seen the light format. It is a representation of a notebook with very few cell markers, none if possible. So this script that I shown was represented in the light format. Now I'm going to show you the percent format. So if I want to change the format of this script, then I pair the notebook with a percent script instead, and I save. And if I go to my text editor, you see that now the script has explicit cell markers at every cell. So it is a more explicit format than if you look at this, you know at first sight that this is a notebook. And even your editor knows about it. And so you can run the script as a notebook interactively if you wish. It even works with interactive plot, as you see. So this percent format is supported by quite a few editors, so Visual Studio Code, PyCharm Professional, Spider, Hydrogen, and PTVS. A different use case if you are writing a documentation, so if your notebook is mostly made of text and not of code, then probably you want to represent it as a Markdown file. And it works great if you want, for instance, to have this Markdown file on GitHub, and it is easy to read. So that's the simplest use case. If you want to write a book, then you should be using the mixed Markdown format because that format has additional functionalities like cross-references and bibliography. And finally, if you plan to edit your notebook both in Jupyter and in RStudio, you should be using R Markdown. Awesome projects that use Jupytext are Jupyter Book to write a book made of notebooks, Plotly.py, they use Jupytext for their documentation, and AI Habitat by Facebook Research is an example of a repository where notebooks are linted using isort black Jupytext in a pre-commit hook. Thank you for listening. I will be happy to take a few questions later at the conference, and otherwise you feel free to open an issue on GitHub. Goodbye.